have, and we've got what I'm sure will be a couple of great talks. Emily will be talking about EHR data quality, federated and centralized approaches, synergies between them. And this is obviously a key thing given the work that we do and the nature of the Enclave. So that should be really interesting. And then Enclave analysis tools overview, something for everyone, by Shawn ONeil. And next Monday, two presentations. Brajaj Patel and Scott Chapman, N3C cardiovascular disease team, and we have quite a lineup. So we're November 8th now, and so November 15th is the N3C cardiovascular disease team again. The 29th, a report out on long COVID, led by Melissa, as well as Emily and Andrew. And then December 16th, COVID reinfection by Jing Su and Umit Tapalaku. And December 13th, outcomes of SARS-CoV-2 infection in patients with chronic liver disease and cirrhosis. So yeah, it's very exciting. The domain teams are maturing and really coming up with some nice results. And actually, I just showed this slide to a different group, saying that yes, it is possible to have an enclave with lots of regular contributors. And not everybody necessarily believes this. So 66 sites is quite remarkable, with roughly 3 million presumptive COVID positive patients, which is in some sense perhaps not very good news, given that COVID is not been extinguished as quickly as we all would have hoped, but hopefully we're making progress. Okay, so Emily, I yield the screen to you.
Okay, perfect. Can you all see the slides okay?
Yes.
Okay, great. So thanks so much for having me today. As Jill mentioned, I'm going to be talking about N3C data quality, but actually you can apply these lessons that we've learned about N3C to really EHR data quality in general. And I think that the way that I've started to frame it after over almost 2 years working on N3C is that we are striving to achieve data quality somewhere between pragmatism and perfection. And we know that EHR data quality probably will never be perfect in terms of data quality, but our goal needs to be to make it as good as possible to support as much high quality research as possible. And I think that's what we are achieving with N3C. So I'm going to do my thanks in advance so that I don't run out of time, because this work that I'm going to talk about today was really the result of contributions from a number of people. We were lucky enough to be selected as a paper in Jamia's upcoming special issue about best practices in data repositories. So the author list that you see here is for that paper. So all of these folks had a part to play in the work I'm about to present. And I also want to make sure to thank all of our consortial authors who are wrapped up in that last author there, the N3C consortium, as well as our contributing sites, because there is no N3C without the contributing sites. And as Joel said, there's now 66 of them released in the Enclave. And all of those, plus the ones that are in flight right now, have just made an incredible contribution here. So I want to make sure that everyone receives my sincere thanks for that. So I want to start with something that I heard early in my career. I had just provisioned an EHR data set to an investigator, as was my job at the time. And the investigator responded with this statement, copied my PI, which was awesome, and said, "This data is junk." Definitely not happy with what I provided. And you know, my feelings were a little hurt, especially because I am a huge stickler for data as a plural noun. And I really wished he had said these data are junk, but he didn't. And when I got over that, I realized that he probably had a point in some ways. I don't actually believe EHR data are junk, and I've never believed that. But one thing that I do believe is that I think the informatics community, myself included, could probably do a better job of conveying how complicated data quality is when it comes to EHR data and the different caveats that you really need to keep in mind in order to successfully use EHR data for research. And so ever since this time, I've really made it my mission to do exactly that as much as possible. And I think we've been able to achieve that in great measure within N3C. But N3C was not the first group to come up with EHR data quality, far from it. I want to spend some time talking about our forebears, who are the federated data networks. And I'm talking about specifically Odyssey, pCoreNet, I2B2 ACT, and Trinetics, which are the 4 data models that we ingest as part of N3C. And those networks have been doing data quality work for a very long time. And we were fortunate that we were able to build on the foundation that they set. And, you know, though I think that the centralized approach that N3C can offer or does offer, it does have some different capabilities from the federated networks. We certainly owe a lot to what they've come up with. So just as an example, federated data quality checks certainly check conformance to common data model rules. So if you have an OMOP data implementation at your institution, and you run what you see here on the right side, the Odyssey data quality dashboard against your data, you're going to get a scorecard of how your data does when compared with the checks that the data quality dashboard chooses to run. So you're going to see things like if a data field expects only a 1, a 2, or a 3, and you have a bunch of A, B, and C in there, you're going to fail that data quality check. And so there's going to be these conformance checks that enable you to make corrections as you go. In addition, these data quality checkers also go a little deeper, and they look for anomalies in data, some implausible data, like if you have a bunch of 60-inch tall infants, that kind of thing, as well as excessive missingness in certain areas. And you'll see the other example I have on the right side is the pCoreNet data curation, which does a very similar thing. And each of these network checks are designed to look at your local site's data and enable you to have better data quality for your local implementation, but also to better comply with the rules of a given common data model. And what they're not really able to do is to compare your results to others across the network and enable you to kind of harmonize, not just on the common data model, but against sort of best practices and business rules and the kinds of things that really can differentiate one site's data from another. That's just not the intention of these tools, and that's totally fine. That does run into some issues when there are particular data domains that are very different between sites. And my favorite example of a data domain that is very different between sites is the visit or encounter domain. So you can see in this example that, you know, let's just say that I ask sites to run a query in their common data model to count how many visits are COVID visits, have a U07.1 diagnosis. Site 1 might say, well, you know, we have 43 inpatient visits that qualify, and site 2 might say 27, and site 3 might say they have 806 qualifying visits. And that's obviously very different. Now, I don't think site 3 is wrong because site 3 ran the same query that site 1 and site 2 did. But I do think that it's highly likely that site 3 probably defines an inpatient visit really differently from site 1 and site 2. We see that a lot in the visit domain, where some sites define an inpatient visit as just one visit that encompasses the whole length of stay. And then some sites you know, actually make a new visit for every day of an inpatient visit. So a 30-day stay becomes 30 different visits, lots of different variation there. And you can see how that can be difficult from a data harmonization standpoint. You're complying with all the rules of your common data model, but you have these business rules that don't really enable themselves to be reflected in the rules of the common data model. And you run into situations like this. So if you can pull all the data together in a centralized repository like we've done in N3C, that enables you to look at all of the row level data kind of mushed together the way that I have in this example table here. And if you're a hypothetical analyst looking at this, you can see that site 3 is one of those sites that makes a bazillion rows for inpatient visits. And it's not that they actually have 806 distinct patient encounters. So this is the kind of work that I think has been really exciting to see enabled with N3C. And we're going to talk about that a little bit more. So I think a lot of you have probably seen this slide before, but I'll just do a quick refresher in case it's helpful, because this pipeline is really the core of our data quality process. So when a site submits data to N3C, they can submit as one of the data models on the left. And then when that payload hits our SFTP server, we pick it up and run it through our mapping pipeline that maps variables in the source data to OMOP variables and value sets in the source data to OMOP value sets. Before we release those data though, so after we do that transform, but before the release, we do a very specific set of data quality checks against those data to make sure that they're ready for release. And it's this centralized data quality check protocol that I'm going to be talking through today. So, I talked about being between pragmatism and perfection, and this is really where the pragmatism part comes in, right? Because there are some things that we can't do with N3C. One thing that you can do with local data that we cannot do with N3C is to check the values against source systems. And so, locally at UNC, if we have questions about our data, the analysts on my team can pull up Epic on one window and actually compare the data in the EHR to the database. Cannot do that here, so that is something we just have to contend with. We also, and this is probably the biggest difference, we have 4 sets of structural constraints for the 4 data models that we accept, plus 1 extra transform because we accept 4 models and then transform them all again to OMOP. And that means that, let's say that something is required in OMOP and a given site doesn't have it. If they're a PCORNet site or an ACT site, and they're still following the rules of their original data model, just not the OMOP rules, we can't really ding them for that, nor would we want to. And that's something that's been really interesting to get used to because we have to remember a lot of different structural constraints. We also, kind of going back to that visit type example, we need to accept a lot of local idiosyncrasy because that's just the way things go. So if that site 3 that says they have 806 visits wants to submit 806 visits, then we need to be totally fine with that because that's their business rules. Now, that's fine, but multiply that by 66 sites, and that's a lot of idiosyncrasy. And so we need to learn how to sort of convey the differences between sites without not accepting it or saying it's poor quality, which it's not necessarily at all. And then finally, our priorities, N3C's priorities for data quality may not match with site priorities for data quality. And, I know very well, as I know many of you do, how much effort and work it is to maintain a clinical data warehouse locally. And you may have a million things on your list for data quality improvement. And if I call you up and say, we found something, maybe that becomes thing 1,000,001. And I think that depending on what the thing is, if it's a critical error and we can't accept the data until that's fixed, that's one thing. But if it's more of a nice to have, I think we at N3C just need to accept that you will get to it when you get to it. And we just need to sort of meet in the middle that way. And that's pragmatism there. So I wanted to share this example of how difficult it is to deal with 4 different sets of rules. And this is just one example, but I think death data is a particularly good example case for this problem. So all 4 models support death data, no problem there. But you'll notice, and I'll just use the PCORNet as an example here, that death data in PCORNet is not required to declare a patient as deceased. It is required, however, in OMOP and also in Trinetics and also in ACT. And so if we see that there is a patient that doesn't have a death date, once the data has made it all the way through a pipeline and is now in OMOP, that row no longer complies with the OMOP rules. But it wouldn't be terribly fair for me to go back to the site and tell them that they have to populate that death date because they were following the rules of their original common data model. And so these are the kinds of design decisions that we've needed to make as a team at N3C to sort of get as close to being OMOP compliant as possible while recognizing special circumstances like this. There are probably 100 other examples just like this in different data domains. So I apologize in advance. The next 3 slides are pretty text heavy, but I will try to limit the reading of this text. What you're going to see here are our minimum checks that we require in order for a site to pass through the data quality process and hit that release. And I'm not going to go through every single check that we do, but I will give you the highlights. So the first thing that we do make sure is that the site is actually following the rules of their original CDM as much as possible. And so, for example, if there are tables and fields that are required in their native CDM, we make sure that they are populating those fields and those tables. If we don't know that the data that came in was compliant with the original CDM, it's very difficult for us to translate that and transform it to OMOP. And so that's just sort of a initial thing that we need to make sure is correct. In terms of demographics, this is where things get a little squishier, right? Because here's where we're looking to see if the patients that qualify for a COVID phenotype is reasonable. Now, one's definition of reasonable differs heavily between sites and geographic regions and time of the year and time of the pandemic. But I'm talking about things like if your site submits that you have 50 COVID patients over the entirety of the pandemic, I'm going to say that's probably not reasonable. So those are the kinds of swings that we're looking for. We're also looking to see if demographic distributions for sex, race, ethnicity, month of birth are sort of plausibly distributed. And again, that differs too based on a site's geographic location and things like that, but we try to keep that in mind as we're checking. It won't surprise you that we do a lot of checks on COVID tests because that's the focus of N3C. So we demand that all COVID tests are coded in a standard way. And that could mean using an OMOP standard concept if you're an OMOP site, but if you're not an OMOP site and you use one of the other data models, we just are making sure that you're following the controlled vocabulary for that data model when you're submitting your COVID test data. And it's not just the tests that we need to be standardized, it's the results too. So we need to make sure that even though there are different sort of synonyms for things like positive, negative, detected, not detected, we accept all of those, but it's a relatively small set that we're comfortable with. And we make sure that sites are doing the best that they can to get their results in that relatively small controlled vocabulary. For conditions, this has been a very interesting ride because US 7.1, which is the ICD-10 code for COVID, was a new ICD-10 code back in April of 2020. And usage of it at different sites has varied wildly. And in addition to that, because it was a new code, there were many ETL processes locally at sites that weren't accounting for it to begin with because it just appeared in the data one day. And so we do make sure that US 7 is appearing in your data and that it is occurring at a reasonable distribution of visit types. So you don't have all your US 7.1s in inpatient visits, for example. Now, encounters are a little bit wild, as we saw before, and we don't really impose a whole lot of deal breaker checks on visits, but we do look to see that visits are distributed across a variety of visit types. If you have 100% inpatient visits or 100% emergency visits, that doesn't generally seem plausible unless you are a very specialized healthcare system. And so we have actually spoken with a lot of sites about this, and it's usually a mapping issue from source system to CDM. So a lot of sites have made improvement in that space. Many of these other checks are sort of things that are really important from a data cleanliness perspective. They're less interesting to discuss, but one example is that we make sure that if you have a person ID in your tables, that person ID exists in the person table. Sort of really basic checks like that to make sure that there's some kind of referential integrity between tables. And then the final one that I wanted to touch on here is this fitness for use check type, because this is the squishiest of all. The fitness for use is really based on the input we get from researchers using the data as opposed to our checking process that we do before release. There is literally no way that we as a data, we call ourselves the data issues team. As a data issues team, we would not be able to do every possible data quality check on the data. It's just, there's too much, there's too many variations, but researchers have been incredibly useful in submitting, problem tickets, issue tickets about the data as time has gone on so that we can look into it deeper. And often we find things that sites can and do correct. So that whole sort of secondary part of data quality where it's actually being used for particular use cases and problems are being found and corrected there has become a very important part of our data quality process. And I'm not going to go through this in detail, but this is a table that we have in our paper, which kind of represents the top 15 errors that we see in site data the first time they submit. I don't know that there is any site that has made it through the first time they submit with no feedback from us. There may have been one or two, but it's pretty rare. Most sites have at least one thing that we catch, and we tabulated all of those issues up and sort of categorized them and came up with these top 15 heuristics for data quality. So even though I'm not going to talk through all of them, I am going to give a couple of examples that I think are particularly instructive that we used in the paper. So one of these is number 2, which is that the issue here is that the site's COVID test results are not standard. So maybe instead of positive and negative, they're just using string values of P and N. That's not something we accept. And so we would ask a site to correct that. What you're looking at here is data quality over time by site. So each colored line is a site. And of course, we're not representing all sites here. We're representing sites that have this issue. And up the y-axis is the percent of a given site's COVID tests that were invalidly mapped. So you can see this orange site here had no valid COVID tests. This green site here had 60% invalid COVID tests. Regardless, we want to get that number as low as possible. And you can see that through our feedback process, which I'll talk about in just a minute, we were able to help these sites get from, high numbers of invalid tests to almost none or none just a few releases later. So we felt pretty good about this because not only does it improve our data and it makes our COVID test results more normalized, we can release that site, but it also improves the data quality locally at those sites. And we heard a lot of positive things from sites about that, which sort of gave us the indication that we were doing something right. Another example is back to this visit type issue, where we're looking for a distribution, a sort of plausible distribution of different kinds of visits. And what you're looking at here is just the percentage of inpatient visits. And we have some sites that had way too few inpatient visits and some sites that had way too many inpatient visits. So you'll see here in the A side, this particular site had way too many inpatient visits for its site. The site that it was not reasonable to assume that, around here, 15% of their visits were inpatient. That was very high. We worked with that site. They did realize that there was a mapping issue in source, and all of a sudden that percentage plummeted down much closer to the mean, which you can see down here. And this is exactly where we wanted them. The opposite problem was that some sites had almost no inpatient visits or 0 inpatient visits, which we also knew was implausible. And though this is quite variable, so some sites really do only have 1% inpatient visits. Some really have as high as 5 or 6% or more. There isn't a right answer for this, but you can see that all of the sites that we gave feedback to, and again, these were mapping issues at the source, were able to improve their percentage of inpatient visits to something that was much closer to where other sites were. So, given those examples, how did we get from data quality not optimal at these sites to data quality more optimal? Well, we have the same cycle that we go through for every single site that works with N3C, and we're very proud of the relationships that we've established with sites. And so, we get data from sites and we do that quality review, as mentioned. We send the feedback to the site, and those sites, for the most part, already know us. They've come to Phenotype office hours. They've received, lengthy documentation from us on the data submission process. So we try to basically make friends with people. And so when they get that feedback from us, it's really sent, with a, hey, this is important to check for your participation in N3C. These things are deal breakers and we won't be able to release your data until these things are fixed. And oh, by the way, here are some other things we saw that you may want to look at when you have time. And, 99.9% of the time, those corrections are extremely well received, and the site goes ahead and makes those corrections as best they can. They resubmit the data and we go through the whole process again. It doesn't matter if we have to go through that process 1 time, 2 times, or 20 times. We have seen a spectrum of, amount of effort it takes to get a site from first submission to release, but we always manage to get there. So this has been a really useful process for us, and one that I think is pretty sustainable based on some of the really incredible data quality visualization tools that the Palantir team has developed. It really makes it pretty efficient for us to do these data quality checks and enables us to keep going with this cycle. So I want to sort of end here with what is basically the discussion section of our paper. It's sort of saying, why does this matter and why is centralized data quality a really cool augmentation to federated data quality checks that have been in place for years. One of the coolest things I think that we are able to do that is really much easier in a centralized environment is site-to-site benchmarking. So what you're looking at here is a visualization that we actually sent out to sites. If you're a site and you haven't received this, it's because we sent these out around, I don't know, maybe 3-4 months ago. And so if you're released since then, you won't have received this, but we will update these soon. But regardless, many sites did receive this. And what this is showing is the frequency that your site has a particular data element populated versus other sites that use your same data model. So these site IDs are all fictitious, but you can see that for this particular site, that they have much higher coverage of PaO2 than many of their others, many of their peer sites, right? But they actually have a lot lower coverage of some labs than their other peer sites. And so this enables a site to look at what they have on this diagram and try to figure out, is stuff that I'm missing because of we just don't collect that lab, or did I maybe miss that lab when I was writing my ETL? And I have to tell you that when we sent these out, we didn't really know if this was an optimal format or how people would feel about this kind of benchmarking. But I can think of several examples where we heard back from the site and they actually changed their local ETL to populate some of these things where they were lacking in coverage a little bit, because they realized that there was data in the source system that they just hadn't pulled in. Either nobody was using it or it was easy to miss because maybe it was coded in a strange way. But I do think that this kind of benchmarking really allows you to place yourself in with your peer sites so that you can kind of see, maybe I should be looking into why I don't have as many body weight measurements as maybe I should. So this has been really, really cool to see. And I also think that crowdsourced quality is one of the coolest things that we've seen, which goes back to that idea of the fitness for use, the fact that that researchers who are using the data are pointing out a lot of issues in the data that we can then, go back to the site in more detail. So, we've seen that people report that, for example, vitals or labs are reported in weird units that don't make sense. And that's something that is often completely correctable at a site, or that maybe one site is missing some data altogether. And that's an example of something that sometimes that's okay. So maybe site Y just doesn't have a feed from their state death data, and they don't have a feed from their discharge dispositions, and so they're not able to provide that. That's okay, but we need to make sure that we're conveying why that site doesn't have death data to our users so that we don't keep getting this feedback over and over again. More importantly, we want to make sure that people who are using death as an outcome know that site Y is just not going to be able to provide that information. And then there's also a lot of feedback about missingness, especially when things start to look strange. It would be very strange if a given site had no one with diabetes. To me, that would indicate not that there was no one with diabetes at site Z, but that maybe site Z had some sort of issue with their condition ETL that was leaving out important coding information. So these are all very realistic examples of things that have been reported to us and things we've gone back to sites with, and has been very gratifying to see these things get corrected. And then finally, the economy of scale is pretty undeniable. So having more data centralized enables really interesting data rescue efforts that I don't think are nearly as feasible in the federated environment. So one has been the unit harmonization effort that Richard Moffat and Kate Bradwell have led to actually try to infer units that are missing from certain labs based on all of the other lab data we have where the units are not missing. And that's been just a really interesting methodological development that I think would not have been feasible without the amount of centralized data that we have. Another similar effort has been the effort to rescue data from the observation table. So for those of you who are familiar with OMOP or not familiar with OMOP rather, the observation table has a lot of data that doesn't really fit well anywhere else. I'm sure that Odyssey folks have a much better description of that table than I do. But the reason I put it that way is that what you'll often see in the observation table is a real mishmash of stuff that often has local codes attached to it. Maybe it's smoking status, maybe it's discharge dispositions that are being filed in a strange place. There's a lot of good stuff in there. And some of that stuff is really important, good data, but because it's in such a huge bucket of other data, it's really hard to know where that gold lies. But when you have enough of it, you can actually do analyses, as members of the data issue team have done, to try to find patterns in the observation table and find big swaths of data that are all describing the same thing, let's say smoking status, and rescue it. Make sure that it's well harmonized and much more usable for analysts and researchers than some of the other stuff that's in the observation table. So that's also been really gratifying. In addition, there's just some really practical things that are great to have, which is that because there's a dedicated data issues team, dedicated data quality personnel, there's just more eyes on your data. And there's also new perspectives on your data. So, I like to think that, at UNC, we have really good data quality. My team is awesome. I feel wonderful about, what we provide to people. But even we didn't pass on the first time through the N3C pipeline. And that just tells me that having outsiders look at your data and pass it through a variety of checks that you may not have thought of locally, it seems to me have no downside. And we certainly made changes to our ETLs based on that feedback, as have other sites, as I mentioned. So what are the takeaways? I think that the data quality analysts that I work with as part of N3C have incredibly deep subject matter expertise. We have experts from each of the common data models, and now we're sort of all experts in just the N3C environment. And again, as I mentioned, the powerful visualization tools that we have access to really can help sites make rapid data quality improvements in high priority areas, especially as regards COVID, just in a really efficient way. And that is certainly a benefit. I want to reiterate that centralized data quality are augmenting the federated data quality checks. So a great way of looking at that is that if there were no data quality checks at the federated level among the networks, and what we got was just data that sites had put together themselves with no local checks, I guarantee you that we would be wading through hundreds of data quality issues per site, just because that's if you don't have any way of evaluating your local data quality in a standard way, trying to submit to a centralized repository like this is just going to be a bear. And so we're so grateful to the federated checks for doing so much of the work. And then by the time the data gets to us, we're able to concentrate on the COVID stuff. We're able to concentrate on the things that we can see that the federated checks can't. And in that way, I really think there's a lot of synergy between the two types of checks. As I mentioned, centralized data quality enables benchmarking, crowdsourcing, and then those scale-based efficiencies. And then, sort of the final takeaway that I think is that if I was building an ideal data quality checking world and I was in charge of all of the parameters of that, the way that I would build that is a combination of local checks by personnel and data analysts who intimately understand their site's data, know all the idiosyncrasies, and really know where all the skeletons in the closet are too, right? So a combination of that and centralized checking. And that really might represent an ideal model for data quality assessment because you get the best of both worlds. And, I think that we're working toward that ideal. And I really hope that N3C can serve as a lesson and a model for future projects to enable us to continue this synergistic approach between data quality checking methods. So that's what I have today. I'm happy to take any questions, but yeah, I will stop sharing.
Great, Emily, thanks. So we have a bunch of questions in the chat. Can you see the chat?
I can see the chat. I just see one question though.
Okay. Let's see. Increased resources to sites would providing increased resources to sites, monitors, data entry specialists, increase data quality. I can't imagine what you're going to say.
Well, so do I think increased resources to sites would improve data quality? Yes. Do I think that data entry specialists would improve data quality? Maybe, maybe not. Some of the data quality issues that we see in EHR data go all the way back to my first statement from that investigator who told me that the data are junk. And that's because the EHR data is going to be messy and uneven no matter what. We have more data about patients who are sicker. We have more data about patients who come to the healthcare system more often. And so those patients are always going to look different in terms of data quality than somebody who went to the ED once and never showed up again. So there's going to be different missingness levels no matter what you do. There's going to be skew no matter what you do. So some data quality issues really don't have anything to do with the data entry and have more to do with just that's how EHRs are. But increased resources to sites, if, in addition to ruling the world and coming up with a new data quality paradigm, I also had a blank check. I also feel like having more funded effort at local sites to concentrate on data quality would inevitably improve things. And that's just one of those things that if you have limited funding and a bunch of stuff you have to do, you can't put as much energy into data quality as maybe you would like.
And sort of a related question by Daniel Riggins about availability of code to sites so that this could help them do local data quality.
I'm so glad you asked. So there is a lot of code that is available. The entire pipeline that was developed for N3C by brilliant developers is available on GitHub. I don't have a link handy right this moment. If somebody else does, please feel free to put it in the chat. But if not, I can dig it up later and maybe even stick it in the slides. So the entire transformation pipeline code is available. In addition, we can describe all of the, and did describe all of the checks that we're running in the paper, and those were in those tables that I showed. We don't have code for that because running those checks is different in every source data model. But if you have a developer who is skilled in that data model and understands it, they should be able to run the same checks locally, compose some quick data queries that do the same checks. And you can kind of achieve this locally as well. But the short answer to the question is that we do try to share as much code as is possible, and that can be run at local sites.
So I have a question. You were talking about visit type and sanity checking, which makes total sense. But how do you know what to expect from all these different sites as to what a appropriate ratio of inpatient to outpatient might be?
Yeah, that's a great question because it really does vary. And that's kind of why we've really stressed building relationships with the sites as much as possible. I mean, if you're a site that's pretty low touch and, we're not best friends yet, that's fine. But for some of the sites, we've gotten to know them pretty well, and we sort of understand based on conversations with them what we should expect from their data. Those sites are a little bit easier for us to evaluate. I'll just use my own site as an example where, if UNC sent in data that just had no inpatient visits, we would just know that that was not correct because it's a huge healthcare system. For sites that we don't know as well, that's usually where in that cycle that I was showing, the feedback to sites where we start the conversation and say, hey, this looked a little low. Is this actually reality at your site, which is entirely possible, or does this seem low to you as well? And we start the conversation that way. And sometimes the site comes back and says, you know what, that actually is reasonable, and here's why. And then sometimes the site looks into it more deeply, and we kind of go back and forth that way. So we don't really know what is reasonable at site A versus site B. We have to just kind of use our intuition sometimes and rely on the site to fill in the gaps.
Yeah, well, that makes a lot of sense. Okay, one last question, and I'm not sure I completely parse it from Jimmy Funk. Can you see it, Emily?
Yeah, I think that's the need for data features request. What would you recommend for rescuing data from the observation table? The data may be submitted from the offsite. Any metrics for? So that is a good question. I don't know that I have any particular recommendations. I think that one of the issues that we have is that a lot of times it seems like the codes that are used in the observation table are not standard codes, and because or they're what ends up being in the code column, the concept ID column, is a 0, which is the OMOP parlance for no matching concept. And then the rest of the good stuff, the stuff that you're really interested in, ends up being in the source data fields. So maybe you end up with strings in there that are interesting but not well harmonized, or even numeric values where the test or measurement that they're attached to not well harmonized. So I think, you know, and others that know more about the others that are more skilled in the OMOP data model than I am probably would have a better answer than I do. But I think that using standard OMOP codes, if you're an OMOP site, trying to avoid those no matching concepts as much as possible will prevent your data from having to be rescued in the first place. And the rescue efforts will be devoted to those sites that either don't have OMOP or don't use standard codes, but we want to make sure that their data are as well represented as possible.
Okay, well, thank you, Emily. This was great.
You're very welcome.
So Shawn, I think you're up, and Shawn is going to be talking about Enclave analysis tools overview thereof. Something for everyone. Could you share the slides, Shawn?
I'm just going to be doing a quick live demo, if that's okay.
Perfect.
Awesome. Well, thank you, Joel. You know, I tend to come at everything in life as a teacher. I really like to teach people coding and data analysis, and when I can get somebody who hasn't done it before sort of hooked on the power of being able to do that, I just really get a great kick out of it. And so getting involved with N3C has been really interesting because we have this whole very different platform that I'd ever really experienced before in working with our data. And I wanted to just give a quick sort of tour around a few of the tools that are used. If you're not already working in the Enclave, this is for you. Before I start, I want to remind folks, I'm not going to show any real data here, but we have a couple of notional or fake data sets. One is the Cynthia data right here. That's based on a patient encounter, probabilistic patient encounter model, and then the Pfaff data, which is based on an older Medicare data set. So they each have their sort of pros and cons. The Cynthia notional data is more aligned to the real data that we have, the level 2 and the level 3 data. And you can get access to these data sets once you have Enclave access without necessarily getting the DUR. So these are available as soon as you can log into the Enclave. You can start playing with these in the N3C training area project and check out the training portal for info and stuff about that. So the three main kind of analysis tools that are used in the Enclave are what are known as contour code workbooks, which I think are most people's bread and butter. And then we also have what are known as code repositories. And I'm going to start with contour. I've actually laid out a really brief sort of analysis here, but I'm not going to really dive too much into the features of it because I kind of want to focus a little bit more on the features of the platform and how I think about them in terms of, you know, when I work with a brand new student or a clinician who's never done any data analysis before, but really wants to get their hands dirty. And I just, again, love it when I encounter someone like that. So here, for example, in this contour analysis, I've loaded up the concept set members table. This is the table that defines all the various concept sets that have been defined by the N3C community. And then I can show a quick visualization of that table right in line. And what I'm doing is I'm just sort of like starting with a table, and then I can do operations on that table as I go down. So for example, from this concept set members table, potentially I'm interested in looking at finding, you know, patients who've had pneumonia. So I'm going to just go and do a quick filter where I'm going to keep the rows where the concept set name is this one, this non-influenza pneumonia training. That's one that I had previously defined, and I'm going to keep version 1 of it. And then I'm going to remove some redundant columns and get down to like just a filtered subset. In this interface, you can put in these like little table previews, which are great. And then you can also just pop up a table preview down here at the bottom to see what any one of these things is resulting in. One of the neat things about this particular tool is that once you get to the end of what they call a path, you can take the end of this path, and you can save it as a data set out into your project folder. And that way you can reuse it in other tools or other analyses, or you can reuse it as sort of the starting point for another path. And this is sort of like, we don't really have the idea of assigning variables here that you would in code, but this path sort of defines a variable in the sense that I've created this intermediate output that I can use in multiple other input paths. And so that's a really convenient thing to do. So in my next path, I'm starting with the condition table, which describes all of the conditions in our mock data set here. And then I can do an inner join to basically say, I'd like to find the intersection of the table that I have right above it with this other resulting pneumonia concept set that I have over here. And I want to keep all of the columns from, my condition table, but I only want to keep the concept ID from my concept set. And I'm going to match on the concept ID. And what this does is it filters down all of the data to just the cases of pneumonia in the data. One of the great things about this, when you're working at the data at this level with this sort of like little GUI interface that you have, is you can't completely abstract away the idea of data analysis, right? Like you're going to be doing table joins, you're going to be talking about things like left joins and right joins and inner joins. You're going to have to know what happens if you have duplicate entries in your left or your right table, and so on and so forth. It's not super complicated, but it is enough that it forces you to think a little bit about the data analysis that you're doing, and it actually does, I think, or I hope at least, makes it a little bit harder to make mistakes. It's also not completely GUI driven in that every once in a while you might have to write a little bit of code. So for example, if I want to know how long the cases of pneumonia that I've pulled out are, I might have to do an expression board here where I can include a function like this and just say, hey, give me the difference between these two date columns, and then call a new column of condition length days to have that. And that adds into my result table down here that I've now got this condition length, which tells me how many days that case of pneumonia was. And then from there, I can sort of pick up and go to another path here. If I want to know a little bit about the demographics, I can do another join. So I can start from the end of my previous path, and I can join in information from the person table, right, which includes information on potential year of birth. And I'm going to do the match on the person ID from the condition table to the person ID in my person table. And there are even some cool, easy visualization things that you can plop into here. So here's a quick heat map. This is my favorite one in Contour, the heat map, because it's a very useful visualization where I'm sort of plotting, okay, according to year of birth of the patients, how long were their pneumonia cases. One thing to note here is that this scale is broken right down here at the bottom. That's sort of an unfortunate feature of this limited visualization tool. And then as we go on, what I can do is I can just sort of take my result and I can save it as a data set to my project folder. So now I have, my pneumonia cases with a little bit of age information in there and the condition length, and it's saved back up. So that's sort of the kind of thing that you can do with Contour. And again, the things that I really like about this, you can talk about filtering and manipulation of tables. You can do joins and outer joins and inner joins. It's not completely code free. Someone who's using this might need to actually do a little bit of code. One of the great things about it is that it includes some really great help text. I don't have a demo right now, but if I were to start typing date diff, it would actually pop up with a little help box that would tell me what things I should be putting in there in order to compute the days and stuff like that. So you get acclimated a little bit to reading documentation about code and talking about APIs and things like that. Once you have a data set saved out, you might want to go into a researcher's more bread and butter, which are the code workbooks. A code workbook is a really cool tool where you can sort of import data sets like this. I'm importing the measurement table here. And then you can transform those data sets with bits of code. So for example, this is the measurement table, which contains all of the lab results in this notional data set. So what I'm going to want to do in this little funky analysis that I'm doing is I want to filter down to just the COVID positive patients. So in order to do that, again, I'm going to need to go back to my concept set members table, and I want to pull out the concept set that describes all the concepts for COVID lab tests, you know, our PCR and antigen lab tests. And that's this one. And it's very much the same thing that we saw in Contour, except now you're seeing the full SQL code that can be used to generate that from these two tables, or from this one table. This and this then can be joined with more SQL code, where I want to say, all right, do an inner join. And again, I'm not using the GUI. Now I'm sort of going into more of a code-based environment where I'm writing code that does the join and results in the resulting table that just has the COVID labs. But those are, of course, both the positive COVID labs and the negative COVID labs. There's another concept set that Emily alluded to, which is the COVID positive concept set, which is the different ways to encode a positive lab result in ONeil. And we can pull that concept set out. Here I'm demoing doing it in R. So if you want to learn some R, you can do that in the Enclave too. Data sets come in as R data frames and they're returned as R data frames. And so once I have that concept set and all my concepts or all my tests, I can filter down to just the positive lab tests. And if you want, you can do that in Python. You can use Python with the pandas library to work with these two as data frames. And then as kind of a bonus, you know, this tool has really great features for visualization. So I can very quickly produce a heat map in R with ggplot2 using this sort of code-based tool. One of the things that I like about code workbooks is that it sort of really encourages good code organization, right? Because every node here is really sort of a well-defined unit with well-defined inputs and well-defined outputs. And when you're teaching brand new people how to do data analysis and coding, that's something that can really be important and people can struggle with. Whereas in a tool like this, you have sort of this graphical computation graph workflow, and you are forced to write proper R functions that take parameters and return parameters and proper Python functions that take parameters and return parameters. The good thing about Contour is that it's built on top of Apache Spark. So all the things that you do in Contour are built upon this Apache Spark, which underlies all the data analysis in the Enclave. And so this is also a really accessible tool for people who need to do big data analysis, but don't necessarily know how to do Apache Spark. This can work with all 10 billion rows of our data without any trouble. When you get into the environment of a code workbook, however, R and Python become a little bit too lightweight. They can't necessarily load up that much data all at once into memory. And so you may need to find yourself using Apache Spark libraries like PySpark or Spark R. And here, you know, it's basically just different syntax for the exact same stuff. And so this is also a really nice way to look at overlap of the kinds of concepts, not to draw a bad pun, that you use in data analysis, whether it be, again, joining, selecting, filtering, visualizing, and considering very carefully what the details of that are. And then finally, I want to wrap up. Here's a code repository. So this particular workbook ended up by creating a set of my COVID lab positive patients. And then a code repository is a much more developer focused tool, much less GUI. You have a full, usually it's in Python, folder structure with files and functions that are defined in those files. And the way it works here is you sort of define the data sets that are going to be coming in via Enclave specific code wrappers like output and input table definitions that you reference by Pfaff. And so you can do all your code analysis in something that looks like a much more grown-up IDE here, complete with lots of folders and things, and it complaining at you about your syntax. What I think is cool about code repositories, they have a couple of features that code workbooks don't have. You can, for example, output multiple outputs from a code repository, whereas in a code workbook, each chunk of logic here outputs one single table that can be consumed by a downstream one. That's not a requirement here. However, code repositories do have a limitation in that they don't support R. So you can do SQL and Python, but not R. But you can also do Java, as we recently learned in our Enclave users group this past week. The other really neat thing about code repositories is that they're very much more built around a team-based coding workflow. So you have all of your Git features like branching and tagging. And if you want, you can lock down your repository so that certain branches can't be changed. The way that you enforce changes to the code is you force someone to create a new branch, make their edits, and then they have to make a proposal or create a pull request, which then goes for review by whoever owns the actual code repository. And so this is an interesting way to sort of get acclimated to sort of team-based code development and tools like that. Now, we only have 2 minutes left in the hour, so I do briefly want to mention that I think that there are some limitations of the platform here that make it a little bit funky for brand new learners. One is that, for the most part, it's tables in and tables out, whereas of course in general programming and data analysis, we might do a lot of things with strings or other kinds of data types, whereas here, we're talking mostly about tables. There's a very Enclave specific execution environment. I don't open up Bash and run my code or do something a little bit like that, which makes it a little bit hard for folks who come in here and learn this way to translate what they've learned into a non-Enclave environment. So you're starting a little bit further down in the learning pathway than I would have ideally liked. And then lastly, of course, because everything is backed by Apache Spark, there's a brief moment whenever you want to try something where you sort of have to wait, 5 or 10 seconds to see if you had your typo or missed the parameter that you meant to include in whatever function it was. So with all that said, I just wanted to reiterate, I think it's a cool environment for learning. I've had good success teaching people here who've never programmed or done data analysis before. It really makes me happy because, as a general philosophy, I think it's better to teach a domain expert how to code than to teach a coder everything to know about a domain. So thank you for my spiel.
Oh, great. Thanks, Shawn. One question. Let's see. Do you think providing increased resources? No, that was to Emily. Okay, well, this is really fantastic and really a sort of good high-level summary for people who might not have seen this stuff before. So okay, well, I think we're gonna wrap it up, and thanks Emily and Shawn, and looking forward to seeing folks next week.